Hi, I'm Piyush Jain pursuing my computer science from Bennett University. Today we'll talk about image restoration. Let us talk about some of the things we'll discuss in this video. The first is what is image restoration? The second are the problems which we can solve using image restoration. The third one is analysis of the problems. What are the types of image restoration? What are the drawbacks of image restoration? We'll also discuss some real life examples of image restoration. And last one will be the conclusion. Let us talk about what is image restoration. The process to improve the quality of the digital image which has been degraded due to various phenomena is basically image restoration. These phenomena can be motion blur, noise, and improper focusing of camera during image acquisition. These all can be solved by image restoration. So motion blur is a blur seen in a moving object in a photograph. It happens because objects move during the time it takes to expose the photo, and the movement gets recorded as a blur. Image noise is a random variation of brightness or color information in images and is usually an aspect of electronic noise. It can be produced by the noise sensor and circuitry of a scanner or digital camera. Image noise can also be originated in a film grain and in the unavoidable shot noise or an ideal photo detector. The most common reason of a blurry photo is an improper use of shutter speed. When we take a picture from a DSLR or any other device, we always see an option of shutter speed. We have to set the shutter speed accordingly so that the image is perfect. The faster the shutter speed is, there's a less chance that there is a camera shake. There are many problems in the real life which can be solved using image restoration, and also there are many problems which already accepted the image restoration process to make their picture qualities better. So the first one is astronomical imaging. There are many societies or many authorities which take pictures of space, of many different things for the research work. So astronomical images are of higher BPP, that is bits per pixel, and it cannot be treated in any normal software like Photoshops and other Adobe softwares. So for the improvement of the picture, the software used is FITS, Flexible Image Transfer Systems, which use the process of image restoration to give us a better quality of the picture, and so that the image don't get degraded and our results are accurate. The other major problem in which image restoration plays a main role is forensic science. Images in the crime scenes, the pictures and the fingerprints clicked in the crime scene is very important and needs to be precised. So to solve the case fast, image restoration is used to get the proper evidences of the fingerprints of the pictures, and no contamination in the picture needs to be there. So we apply the filters, the inverse filter and the Weaver filter based on the PSFs, that is the point spread function, so that the image gets clear and we can match the results. For this, the image restoration is used, and the use of synthetic images to access their capability is also defined. The third major example in which image restoration is used is remote sensing survey. Remote sensing is the acquisition of the picture, a physical picture, through a satellite without touching that object but taking a whole over round of that picture. So we have usually seen in the maps or in the, the satellite processes that the map of the area is distinguished between many things. This is done by remote sensing survey. Usually the degradation of images happens during the acquisition process of image images mostly affected by blur. So to proceed, we need to restore images to higher definition. This is done by the formula of image restoration, and by which we can distinguish the maps, the areas, and we can focus on the particular area we need to see. After analyzing the problems, we have seen there are two different terms, image enhancement or image restoration. They both look similar, but they are different in their aspects. Some of the images are noisy and degraded and needed to be better. So for that, either image enhancement is used or image restoration can be used. Image enhancement focus on improving the original image to show some more details, some hidden details, whereas image restoration is used to improve the image to make the original image, to match the original image. Image enhancement merely improves the subjective quality of the image by working with the existing data. When it comes to image restoration, it tries to reconstruct by using a priori knowledge of a degradation phenomenon. Restoration hence deals with getting an optimal estimate of the desired result. So if we need to enhance the picture to see some accurate qualities of picture, we need image enhancement. But if we need to restore the image to make it as it is earlier, we need image restoration. Image restoration requires to perform enhancement of the image. So what's the basic purpose of image restoration? The purpose of image restoration is to restore a degraded or distorted image to its original content and quality. After that, we can enhance the image by image enhancement processes to get a better view of the picture. A restoration involves following processes. The first one is modeling of degradation. The second one is applying the inverse processes to recover the original image. There are many types of restoration filters we'll discuss in other next slides, but for now we can see the formula how to get the image restored. We have a degradation function h, and the function of the image is processed having the value of degradation function, and after that the restoration filter values has been inserted, and after that we get the restoration image. So let us discuss about the types of restoration filters. The first one is inverse filter. The second one is pseudo inverse filter, which is basically the modification of inverse filter, and the third one is Wiener filter. There are many other filters, but these filters are the basic filters which are used in many areas, in many industries to restore the image. Let us talk about the inverse filter. Basically, inverse filter is the process of receiving the input of a system from its output. It is a simple approach to restore the original image once the degradation function is known. Now here we can see that if we can assume let f be the original image, h the blurring kernel, the idea in inverse filtering is to recover the original image from the blurred image. As we can see, the A is the spectrum of the blurred image and B the formula put in the B spectrum, and we can get the results. From the convolution theorem, the discrete Fourier transform of the blurred image is the product of the DFT of the original image and the DFT of the blurring kernel. Dividing the DFT of the blur image by the kernel's DFT, we can recover the original image. So we can say that inverse filter is basically recovering the image from its blurriness using the formula, and it has a drawback that it shouldn't have any noise in the system. Now let us talk about the pseudo-inverse filter. Basically it is the modified version of inverse filter. It gives more better results than inverse filtering. Both inverse and pseudo-inverse filters are sensitive to noise. So here the H function is estimated to 0. The third one is Wiener filter. Unlike inverse filter and pseudo inverse filter, which are sensitive to noise, Wiener filter can remove the additional noise and input from the image simultaneously. This is the function which overcomes both the other filters, as it can overcome the noise inputs. So Wiener filter executes an optimal trade-off between filtering and noise smoothing. The properties of Wiener filter, the applications of Wiener filters are: it is used in the signal processing devices to produce an estimated or target random process by the linear time invariant filtering methods of any observed noisy procedures. That's why it is far more energy efficient and productive than the inverse filter and pseudo inverse filter. Now let us discuss some of the drawbacks of restoration filters. These filters are not effective when images are restored from a human eye. These cannot handle the common cause of non-stationary signals and noise. As we have discussed earlier, that inverse filter and pseudo-inverse filter are sensitive to noise. These cannot handle spatially variant blurring point spread function, which we say BPF. Now let us discuss about the real life examples in which the image restoration process is used and is very effective. So in this slide we can see that we have a synthetic vehicle number plate, and in the next few slides we'll compare the restoration result of inverse filter and Wiener filter. So in the down pictures you can see that we have used the 1D motion blur and the 2D motion blur of inverse filtering, and here are the results. So in the 1D motion blur, we have used different values of K to get the better result, and the kernel value, which has 10 raised to the minus 5, shows us the better result in both the cases, that is 1D motion blur and uniform 2D motion blur. The pictures are in front of you. You can take a quick look. Now we'll talk about the real vehicle number test, which is used in forensic cases and in some of the police cases. In this, we'll apply a digital restoration technology to a vehicle plate number image from a real forensic case. In these cases, we take the camera, camera clicks the picture of car we need to focus, and it focuses on the number plate, and by that video we'll cut out a picture, and with that picture we need to find the number of that car, the plate number of that car. So here's the process how we find the plate number of the car. We enlarge the image and check the enlarged image and find the last number, as the last number has the greatest chance for the successful restoration. So we just concentrate on the last number. As we can see that when we enlarge the image, we see the last number of the vehicle plate as 2. After that we run the algorithm, and by this we restore the other part of the car and we get to know the car number plate. So in this video we have talked about some restoration techniques. The goals of these techniques is to improve the visual quality of the degraded image. We focus on the discussion of degradation models and the restoration approaches. The inverse filter and the Wiener filter we have discussed earlier plays a keen role in the image restoration. We compare the performance with the vehicle number plate images. Then we have discussed about the real life examples, the real life scenarios in which image restoration is used, and it plays a very important role. In the real life cases, as the noise effect is not that serious, so both the inverse filter and the Wiener filter will show the same results. But as inverse filter is easy to apply, we use inverse filter in most of the cases. So in future work, we'll try to compare the blurred image and the distorted digits and see if we can obtain better recognition. Thank you.